14 years ago, I was living in a terraced house in the northeast of Scotland. This was a rental property and it was of Victorian era. It was a very lovely property to stay in, but I'm going to have to say it cost an absolute fortune to heat up. It was very, very difficult to keep warm and it took a long time to warm up. As a result, it was costing me about £200 a month worth of heating oil to just keep warm. So to go and find this property on the market, know it was built in the 1990s and know that it was likely going to have modern insulation standards, you're going to have to ask the question, why on earth did it have an energy performance certificate with an F rating, the second worst rating you can get in terms of energy performance for a house? So in this video, we're going to look at energy performance certificates. What are they and how are they important? And how are they going to be important in the future? We're also going to look at how energy performance ratings are calculated. And we're going to use this house as an example of how to do that. Now, if you haven't watched my previous videos, my name is Anthony and I own a 9 kilowatt solar panel array up here in Aberdeenshire, Scotland. It's been running for the last 3 years and there are many videos describing the performance of those arrays in great detail. But putting that issue to the side, we're going to look at the wider issue of energy performance. So the first question to ask is, what on earth are energy performance certificates and why are they important? So energy performance certificates were introduced into England, Wales and Scotland in the year 2007. Put simply, they are an official document which describes in summary how well your building performs in terms of energy efficiency. The scale of G represents the lowest possible energy performance that a building can have, whereas a scale of A represents the highest possible performance that a building can have. Since the year 2007, it has been a legal requirement to have an energy performance certificate attached to a property which is up for sale in the United Kingdom. Since the year 2008, it has also been a legal requirement for rental properties to also have an energy performance certificate attached. Now, the certificates last for 10 years in terms of validity, and since those years, there have now been minimum standards which are required by law to have on your energy performance certificate when it comes to renting your property out on new tenancies. From the year 2019, it is now required to have an E rating on your property before you can let it to new tenants. So now that we know what an energy performance certificate is, let's take a look at the very specific example of the energy performance certificate of my house and take a closer look. So here's the energy performance certificate for my house. And what you can see is that it was issued in the year 2009. That's when the previous owners were advertising this property for sale. What you see here is that we've got an F rating. It's an SAP rating. I'll talk about those in a bit more details, but it's a scale which goes from 1 to 100. So as you can see, we've got a rating of 31, which is well within the F rating scale. Have a look at this number here. This number, 240 kilowatt hours per square meter per year. So if you multiply that by the number of square meters, we get 28,000 kilowatt hours of estimated energy consumption for this house. Now, if we subtract 3,000 or 4,000 kilowatt hours for the electricity consumption, what we're left with is the heating consumption for this house of 24,000 kilowatt hours. At 7 kilowatt hours per litre, that's about 4,000 litres of LPG per year. So now I've got a reference point which I can measure my actual performance against. And as it happens, the actual performance of my property has been closer to about 2,500 litres of LPG per year. So we're a lot less than what this official performance estimate was calculating. if we have a look at some of the assumptions, and one of the things I really want to point out is that all of the report is based on assumption and calculation. The only measurements that happen are those which happen when you're selling your property anyway. The dimensions of your house, the dimensions of your floor space and your ceiling space and your wall areas and your window openings. Those things happen anyway during a house sale, so that information is recycled. But in terms of actual thermal measurements, such as a blower door test or a thermal camera, there are no measurements whatsoever. It is all based on assumption. So here you can see that we've got some facts about this house. Most of these facts are true. They're quite generous with the assumptions about the loft insulation. It was actually 100 millimeters of loft insulation, but they were not accurate at all in relation to floor insulation. Furthermore, we had triple glazing at the time. We did not have double glazing. But everything else is accurate. It was coming up with these recommendations for improving the rating to F, and it was suggesting that we could boost it up to an E rating if we replaced the boiler with a band A condensing boiler. It was also suggesting some other measures in the future, such as photovoltaic panels. I do have to say this number right here, 2.5 kilowatt peak, it's rather weak compared to what I've actually suggested. You could almost accuse the surveyor of having a complete lack of ambition and vision in relation to what the energy performance of this place could have been. So that is an example of one energy performance certificate. The next question is going to be, where can you look up energy performance certificates in general? And following on from that, how do you actually calculate what the energy performance certificate rating for a house actually should be? So if you're in England or Wales, you can go to gov.uk/find energy certificate. And you can start now, and you just choose whether it's a domestic or non-domestic property. I'm going to choose an example that everyone is familiar with, SW1A12AA. Find that. Right, number 10 Downing Street. Let's have a look at this report here, DEC. This is a commercial operation. This is a commercial certificate. This is called an Energy Performance Operational Rating. So that's an example of a certificate that you can get in the public domain. You can just look up your postcode here. For Scotland, it's a different location. It is the Scottish EPC Register. So again, if we search for Scottish EPCs by postcode, you can go to here and you can just continue, and then you type in your postcode and you type in this gobbledygook in here. So that is where you can find any energy performance certificate which has ever been published. So all energy performance certificates are produced using what is known as a standard assessment procedure. If we go into here, back in 2009, it was a different procedure, and it has been revised further since then. If we go to the current procedure, which is called SAP 10, and we click on that, and then we look at the specification. So let's have a look at this. And the first thing you see is that there's 199 pages worth of procedure. Let's have a look at some of the basic entities which make up your energy performance. We've got U values, of course we do, but we have also got thermal bridging. And the other thing we need to talk about is drafts. We're talking about air permeabilities in this instance. What all of this does, all of this here, section 1 to section 9, that's only 34 pages. You're just thinking to yourself, well, there's still another 170 pages left to go through. What matters a lot are the appendices. And all of these will describe in detail how you need to calculate every single attribute. But you've got what's known as reduced data standard assessment procedures for existing dwellings. So we can simplify the calculations quite a lot if your property already exists. And you can use assumptions rather than detailed measurements. Brand new buildings, you need to do a blower door test in order to look at the amount of draft that you have going through the property. One of the problems you've got with blower door tests is that they only have to do it on a typical property for a range of properties which are being built. I believe the standard is going to evolve, so you have to do it on every single property. I think that's a better way of doing it because it means that corners don't get cut on the other properties that you didn't measure. So all of that is built in, and there are actually some quite good sources of information. We're going to have a look at that in a bit more detail. So now that we know what the procedures are for calculating energy performance certificates, you might be thinking to yourself, it's a bit overwhelming. Can you get any help with determining the calculations for your own building? Let's go and take a closer look at what options there are. Well, if we go back to the gov.uk website on the standard assessment procedure, we have a look at SAP 10 again, and we scroll down to what's known as the current approved list of SAP software. Now, all of this software is licensed software. You have to pay for it. But I found out about Elmhurst Energy Systems. And if we go through Elmhurst Energy, we get to what's known as Design SAP. Let's scroll down to the bottom. And what have you got here? You can get a 14-day trial of their software. So I requested that. I got username and password for the post. And once we got to here, we got into this page. After we got through the login procedure, I clicked on Design SAP. Okay, so this is what we get. You can see I've already made up my house, but I'm going to just go through the basics of how to make it. So I'll just call it YouTube, and I'll call it me. Now click on plus. We've got a reference number. So got all of that. That's a bit more interesting later on, but not for the sake of this. Save that. Click on yes. Now we've got the YouTube. Okay, so on left we've got my house, and then we've got YouTube. So click on ... here. Then we've got some subgroups. So we want to add a subgroup. No, we'll just click on refresh. So here we've got plots. Okay, so this is where things start to get a bit more interesting. We want a region, Scotland. We want Northeast Scotland. Enter a client. House name, not particularly exciting at this stage, so we'll just simply save this for now. Right click on this. No, here we are. Assessments. So this is where the magic starts to happen. So let's just add some data. So dwelling orientation, we'll call it southwest. Calculation type, we will call it an existing dwelling. Property tenure, it's owner occupied. Transaction type, let's call it a marketed sale, just to keep things constant. Terrain is rural, and then we can leave those items blank for the time being, and we'll click on next. Property type is a bungalow, and it's detached. And we enter a date built. Well, it's 1993, so we can just go to here. Enter electricity tariff. We'll just call it a standard electricity, and we'll just leave that unticked for now. So then we click on next. Measurements. So we need to talk about the internal floor area. It's 120 square meters. So this is something I made up in SketchUp. So we just add up all of these external dimensions. Okay, 47.4 meters. So let's go back to here. 47.4. So it's story height. That's the height from floor to ceiling. So that's 2.4 meters. And we don't have a heated basement. So living area, I'm just going to call it 120 square meters. So we'll just save that. Now we go to the walls. So I'm not going to focus on internal partitions. If you want to be more precise, then you can be. Let's have a look at external walls. So we'll just call this old insulation. And then the type of wall it is a timber frame. And it is a timber framed wall with one layer of plasterboard. I'm not too sure about what 2 layers of plasterboard is. Now, U values. Let's talk about U values. So have a look at these materials. This is some of the basic materials you've got for insulation in a house. So fiberglass has got a thermal conductivity of 0.04. What do you do with the thermal conductivity? You divide it by the thickness of the material, and then you get your U value. So the thinner your material, so if I choose 10 centimeters instead of 30 centimeters, the bigger your U value. And we want the smallest U value possible. If we're talking about glazing, we'll deal with that automatically in the tool. So let's go into here. So for timber framed walls, we had fiberglass, and that fiberglass had a thickness of about 75 millimeters. No, let's call it 70 millimeters. So that is 0.07. So that gives us a U value of 0.57 for the walls. So let's put that in, 0.57. And the gross area is basically going to be the perimeter multiplied by 2.4. So yeah, 47.4. And that was 113.76 square meters. So we'll save that. And we won't add any more external walls. So let's go onto the roof. We'll add a roof. We'll just call it the external roof. And it is a slope roof. Construction is going to be plasterboard insulated at ceiling level. So that's what we want. So U value, let's go back to here. So again, we're using fiberglass and the thickness is 10 centimeters. So then we get a U value of 0.4. Gross area is 120 square meters. It's going to be the same for the floor and the ceiling. We'll go onto here, the floors, and we'll add the floor. So it is a ground floor, and it's timber. It's a single story, and it's suspended timber insulation between the joists. Again, it was fiberglass, and it had about 7 centimeters of thickness, so that's 0.07. So that gives us 0.57 as the U value. I won't worry about those. Area is 120. So now we save that. And now we're talking about openings. So you need to get your tape measure out, and you need to measure the height and width of all the windows. Now I've already done this. So what we're going to do is describe different opening types. So we have got front door, data source. We'll just use an SAP table, and it is a half glazed door. Glazing type is triple glazed with, I would call that, it's a composite triple glazed door. So let's call it low E. It was about 11 years ago that I got it. So let's call it soft, because I can't see UPVC here. Glazing cap, I would say, is 16 millimeters because it's quite modern. Filling type, I would say, is argon fill, but I don't know that for sure. Frame type is PVC. And then you save it. It calculates the U value for you. So then we do it for the back door. So now we've set up all the different types. Now we need to define the openings. So first opening is going to be front door. And what's the difference between an opening type and an actual opening? We'll apply it to the old wall. We'll apply it to the southeast. Total area is 2 square meters. So that is everything. And we're just going to go with default thermal bridging. So we're not going to add anything there. Ventilation. Again, I'm not going to look at this in too much detail. I will just simply put a value of 1 there. And pressure test, got no information on that. So we will just simply, it will go to an air tightness reference. I'm not too sure what that is, but we did not have any information on that back in the 1990s. So we'll just save that. Lighting, or list of lights, let's do that. So we have 30 lights, and we had 30 lights each at 50 watts per luminaire. So that is 1,500 watts, even though you don't have them all switched on at the same time. That doesn't matter. So let's see, efficacy. So I think it was about 10 lumens per watt. So then it can figure out how many total lumens you've got. That's fine. So we save that. And then we go to the main heating. So we have got a database, and we can enter a database reference number. So I had an ideal boiler. So if we go to a boiler database SAP, here it is, building energy performance assessment. So go to boilers. I remembered it was an LPG, and it was a regular boiler, and it was ideal. So we go to here, and as soon as I saw this, it was Mexico, and I think it was 100p. So I then searched that, went to details. This is the number I'm wanting, 5943. So we go back to here, type it in, 5943, and there you go, there's your Mexico. So then all we have to do is select the fuel type, which is bulk LPG. Is the MHS pumped? I'm not too sure what that means, but the pump is, there is a circulation pump. So select that. I'm guessing this MHS relates to the heating medium, which will be water. Heating pump age is going to be 2012 or earlier. Heat emitters are radiators. And we've got heating controls. So it's asking us to enter an SAP code. So let's just search that. What I had at the time, it was just a programmer and thermostatic radiator valves. Programmer, no room thermostat. So we'll just do that. So select that. So now we've got all the data there. Main heating 2. We didn't have any heat networks. We weren't part of that. Secondary heating, nothing there. Water heating, yes, we need to enter some data. So it was based off the main heating boiler, and it was from a header tank, and we had 1 bath, and we had foam insulation, and it was about 38 mil. I don't think it was that deep. So it was 170 liters of hot water, and it was all insulated. There is a shower count here, so we just add the showers. So this is going to be en suite. Shower type, it was vented hot water. Flow rate is fine, and then we had another shower over the bath, so we'll just call that bath shower, and that was vented hot water. So we save that. So we're nearly at the bottom of this. Did we have any renewables? No, we didn't. So we'll just save that. Results. So we've got some errors. So this is the bit where we have to do a little bit of fault finding. So it's saying glazing gap value must be entered. So that was back in the openings, and it was right here. So we have to edit this. So the back door, I think that was 6 millimeters. Save that. And then save this. And then show errors. Conservatory thermally separated value must be entered. Okay. Where was that? That was back in the walls, I'm guessing. Was it openings? There it is. There was no conservatory. So all I had to do is that. And what do you see? We see the SAP rating. It was F. Let's see how that compares to my old performance certificate. So here you can see that we calculated an energy performance of 32 just with the information I put in. And the actual energy performance certificate that we got was 31. So I think that is quite remarkable that we got so close just by entering that basic information into this database. So now that we've got a reference point for the old energy performance certificate, we can start adding all the upgrades I've done to this house and see what impact all of those things have individually on the energy performance of the property. So let's go and take a look at that in more detail. So the first thing we are going to do is go back to the property type. We had a standard electricity tariff and we had a smart meter. So let's select that. Let's go to the walls and we want to add in another wall. So this is new insulation. It is timber frame again. And it is timber framed wall, but this time we're using a different material. We are using PIR insulation. This stuff is twice as efficient as fiberglass. So we've got two different thicknesses. We've got 0.07 meters, and we can use that U value there. And then we've also got 3 centimeters on top of the timber studs in certain locations. So I'm just going to add this all in. Okay, so let's go back to my drawing. So that makes this 54 square meters. You can see that the openings that we entered in for the doors and windows are automatically subtracted. So let's see what goes on now. I save this. So now you can see just by adding insulation to the walls, we've increased it from 32 to 34. It's not much. That's quite interesting. And what I'll do now is add some more insulation to the roof. So let's go to here and we go and change this, edit it. And we basically go back to our U value and we add 30 centimeters, which reduces the U value to 0.13. So let's do that, 0.13. Save that. Now you can see that's gone up further. It's reduced the CO2 emissions a bit more. And you do the same with the floors. So the floors are all made of rock wool, and it's 14 centimeters thick. So we're going from 0.57 to 0.25. So let's put in 0.25 in here. So as you can see, just by upgrading the insulation in the roof, the walls and the floor, we've reduced the CO2 emission. It used to be about 7.5 tons per year. Now it's 5.79 tons per year. So it hasn't done much, but it's done, enough. And we've increased the rating from 32 to 44. So what does lights do? So instead of 50 watts per luminaire, we're now doing 5 watts per luminaire. So we can just reduce that from 1,500 to 150 watts. Let's go to the main heating and let's go to the boiler database again. And we want to select LPG and we want to select regular, and we want to select Valent, and it is a 618 Ecotech Plus, and it is, I don't know which one it is, we'll just select that one. Search. So that is 18213. So we type in 18213. Watch this number, the SAP rating when you do. 18213. Enter the fuel type, bulk LPG. There we go. Flow temperature is going to be enter a value, and we'll type in 65 degrees. So now we are up to 53, and our CO2 emission is down to 4.76. So we've now improved the insulation and the heating performance quite a lot. But watch this. What happens when I change to a mains gas boiler? This is the same boiler. And see what happens instantly to the SAP rating. This really, all we've done is change from an LPG boiler to a natural gas boiler. It's the same boiler, it's Ecotech 618. For me, the fact that you can go from LPG to mains gas and see such a dramatic rise in the energy performance of your house says a great deal about the calculation methods you've got here. People who live in mains gas areas have already got an enormous advantage compared to rural dwellers like myself. And if you have oil central heating, then that's still better than LPG. And what it shows here is that it is cost performance rather than energy performance, which gives you the highest possible rating for your property. The next thing we want to do is go on to secondary heating. Let's go here. We're back to the LPG 53E, and we will go onto an SAP table. And what we're going to do is we're going to enter a solid fuel. So we have got wood logs. There we go. There's a seasonal efficiency rating of 80% for this one. Are we in a smoke control area? No, we're not. And that should be adequate. We'll just do a search here. Okay, so we'll select closed room heater. So it's not an open fireplace. It makes no difference to your energy performance, even though wood firing is a lot cheaper than LPG. So that's an interesting feature to note. It doesn't ask any questions about the heat output either. So yeah, oh, it is heaters approved. So we'll just click on that. So that gives you an extra point. Let's go to the water heating. So it's still main heating. That's fine. The difference is that we are from mains, and that if you go from header tank to mains, that knocks down your rating. Now, if we go to the showers, edit those, and we are now, it's now unvented hot water system. Click on that. So the flow rate's gone up from 7 to 11 litres per minute. Save on that, it's knocked it down even more. So we've gone from 53 rating down to 51 by going to a more modern form of plumbing. So header tanks are good in terms of limiting your flow rate, but they're bad for all sorts of other reasons, including risk of frost damage, which then floods your entire house. I've never liked header tanks in the loft, and I got rid of them quite early on. So the hot water cylinder, it's foam, and it's at 50 millimeters. Let's see what that does. So it doesn't make any difference to the SAP rating. It's the same volume of cylinder. So now we go on to renewables. And this is where things start to get very interesting indeed. Let's choose one dwelling. Is it an export capable meter? Yes, it is. And is there a diverter? Yes, there is. Is there a battery? Yes, there is. 10 kilowatt hours. And let's add some cells. So let's call that JA Solar. I don't think that matters so much. And then we do kilowatt peak. So we've got that southwest facing 30-degree angle. And that is 16 panels, 320 watts per panel, 5.12 kilowatts southwest. Overshading is, let's call it modest. And then save that. So that's brought it up to a D rating. Let's add some more panels. This is 12 panels facing southeast. So it's 3.84 kilowatts, 3.84. Southeast. Elevation, MCS certificate. We've now brought this up from an E rating to a C rating just by having these solar panels and the battery. This investment here for solar panels, that will bump up your rating by 2 notches. So once we get to results, it will come up with some recommendations. It suggests solar water heating. It's suggesting a wind turbine. And it's not recommending any heat pump, which is quite interesting. So what we can then do is make a report. But before we do that, one thing I really want to just simply point out is that we've gone from a CO2 emission rating of about 7.5 tons per year to 3.91 tons per year. So we've made some substantial savings on our energy costs in this house. When it comes to reports, summary information is what you want to do, and then you just generate a report, open that up, and it will give you this rating. It will tell you what the energy performance is. This is not an official energy performance certificate. This is just for fun. So how does my energy performance certificate assumptions compare with my actual performance in my house? I went from burning 2,500 litres of LPG per year, and I'm now down to burning 769 litres of LPG per year, but I've also been burning firewood. That's typically about 3 cubic meters a year, and it's about 7,500 kilowatt hours. So in kilowatt hour terms, I've gone from a consumption rate of 17,000 kilowatt hours per year for heating and hot water down to 12,500 kilowatt hours per year. And in proportionate terms, the energy performance calculations which I derived with that software shows my CO2 emissions going down by the same proportionate amount. And the point of the matter is that energy performance is not supposed to be an accurate representation of your house's performance. It's just a standardized representation. How much you actually use depends on your own personal preferences and habits to a large degree. I am, after all, a single person living in this house. If you have 3 or 4 people living in a house, then you're going to have a higher energy performance load than what I actually do. So the certificate is all about standardization of measurement and calculation. So now that we've got an indication of what the current energy performance certificate of my house is likely to be, let's see where my house could be in the future. What we're going to do is add a heat pump, and we're going to see what the rating of this house could be if we add that to the equation. So what we'll want to do is go to main heating 1, and we're going to go back to the search database on the boilers. Product characteristics database, we can go for a heat pump. We will go for an air source heat pump. We will have an emitter, flow temperature of 45 degrees, service provision, space and water heating all year, brand name, we'll go for Valent, model name, we'll go for an Aurafirm 7 kilowatt, model qualifier, and let's search that. And we'll just select this one, 103779, copy, 103779. So there's the Aurafirm. Let's see what we've got. So that's fuel type, MCS installation certificate, I don't think that matters. This is 2013 or later. Heat emitter is radiators. And we will go into here and we'll change the SAP code as well. We'll do time and temperature control by arrangement. So we'll select that. And here we have a new result. It is a B rating, 91B. So with the aid of a heat pump, along with my solar panels, I could potentially bring the energy performance rating of my property up from a rating of F 14 years ago to B in the not so distant future. I think that's very interesting and worthy of investigation. You now need to have an energy performance certificate in order to gain access to grants and other funding for improving your house. And in the example of Home Energy Scotland grants, one of the requirements you need to have to qualify for grants is that there needs to be no recommendations in your energy performance certificate for improving loft insulation. And this is where differences between different assessors comes in. They have, by rights, the right to make assumptions about your property without even taking a look. So coming through a loft hatch like I have and seeing all of this loft insulation, they don't have to necessarily do that. They can just simply say your property is of a certain age, 1993, and we're going to assume that the loft insulation in your property is of a certain depth. And if it is not correct, then it is up to you as a homeowner to document the actual results of your property. And that, generally speaking, means that you have to provide the EPC assessor with certificates saying that it has been done to a certain depth. And that's a great shame. And the reputations of assessors can vary from place to place. And as you saw in my results, that they made assumptions about there being no floor insulation, for example, when in actual fact there was. And it's a great shame that they don't spend that extra 2 or 3 minutes to check their assumptions against actual facts where they are available. So currently, the future of energy performance certificates is under a lot of discussion right now. For some time, the proposals have been that new rentals from the year 2025 and all rentals from the year 2027 or 2028 must be provided in properties which have got an energy performance certificate rating of C or above. Those proposals are seemingly under review. There's a lot of resistance by landlords to that, and a lot of landlords are trying to sell up their properties right now. But it does raise the question, if minimum standards for energy performance apply to rental properties, could it be the case that if you sell your property in the future that you may have to achieve a certain minimum energy standard? Those subject matters are up for discussion by politicians at the moment, and there are also discussions about the overall measurement standards and criteria for the energy performance certificate right now. I've been reading in a construction news website that the calculation methodology for energy performance could in future separate out building fabric performance from heating performance in new energy performance certificates. So that's all quite interesting, and it goes to show that the whole subject of certification for energy performance is an ongoing story. Well, that's it for this video. One of the things I have been investigating is the subject of installing heat pumps at my house. We have in Scotland a grant available from Home Energy Scotland. It is £7,500 if you live in an urban environment, or £9,000 if you live in special rural uplift areas. Old Rain is one such area which qualifies for the £9,000 grant. I'm going to be talking about heat pumps in a subsequent video, but in the meantime, I'd like to thank you all for watching, and I'll talk to you again very soon.